let's dive into week 2. All right. So you have your review questions due Tuesday night. Robbie the Robot, we already touched on. Just be aware of these due dates. And then you have your peer review journal and your self-assessment survey. Okay. Again, with the peer review journals, all I'm wanting to know from you guys is how you're doing. If there's anything that you're struggling with in the course, any questions or anything that I can help you with. Or if you have any fun jokes, you know, anything. So that's what your journals are for. Any questions on your deliverables for the week?
I have a quick question on the Robbie the Robot.
Okay.
That's Amanda, by the way. Sorry, I was
No, you're good.
logging in. So for the where it says the practice, where you can like practice, I tried clicking on that, and it said that access was denied.
Okay, so Amanda, you just missed this, so I'm going to go over this quick. It's okay, you're good. So I'm going to go over this quick, and then if you have questions, just check out like the first 2 minutes of this recording.
Okay.
But it is a little bit convoluted. Long story short, you click on the instructions, but you can't practice it there. So come back out to the modules, click on the final code, submit, and that is where you can practice. Once you feel like your code's in a pretty good spot, copy the code, put it in the peer review discussion right here. And then once you're all done there and you're confident your code is like ready for your final code submit, come back to the final code submit and submit your code.
Okay, sounds good. Thank you.
Yeah, it's a little bit confusing. And it's just confusing because they didn't put the animation thing inside of these instructions. So anyway, sorry about that, you guys. Amber, welcome. Glad you could make it. All right. Any other questions outside of those? All righty. Well, then let's look at chapter 2. If anybody hasn't read chapter 2 yet, that's okay. It is on algorithms and computer programs. So algorithms, all right. Basically what it is just a list of steps to perform a task, all right. These could be a lot of different things. If you think about something that has a list of steps to perform a task, I could think about like a recipe. You know, I have a recipe. I'll have, you know, like, hey, blend in 2 eggs, add some oil and water and the Costco brownie mix that you bought because you're too lazy to make brownies, you know, whatever, blend them together, cook it. That could be defined as an algorithm, okay, just a list of steps to perform a task. Okay, I put Boromir in there with one does not simply write an algorithm because a defining table can really help you out with this, okay. This is a useful tool to help you understand a problem, to conceptualize the input, output, and processing of whatever you're working with, all right? So in our code throughout the semester, you will have a defining table, okay? Now, I could look at a defining table as literally being a table like this, but in your code, you won't actually have a table, okay? Let me just show you this real quick. So this is an HTML file. I know there's a lot going on here, and we haven't touched HTML yet, but there's a thing in code called a comment. Okay, in JavaScript, all right, I have this script tag here and a closing script tag here to say, hey, everything between these tags is going to be JavaScript. Okay, in JavaScript, I can have a multi-line comment just by starting off with these characters /**, and then I end the comment by saying ***. Okay, if I remove this, you can see it made the rest of this a comment because I never ended my comment. And if I remove this, then none of it will be a comment and it has no idea what I'm doing here because that's not JavaScript, okay? But because this is a comment, I can put anything in here I want to, all right? And so my defining table, I'll just have an input and I'll just write it out. I'll be like, yeah, my input is like eggs and oil or whatever. And then my processing could be like mix and preset oven to 375, okay? And then my output would be some delicious brownies, okay, just for example. But to help you conceptualize this, we'll go ahead and start with an actual table that we're used to seeing, okay? So for this example, imagine that you work for a large construction company. Your boss has asked you to write a computer program that will read a list of window openings for a building and compute and output the total cost of all the windows. The window openings are entered in inches with the width first and the height second. The cost of a window is computed by multiplying the area of the window in square feet by 35, all right? So looking at this, what do you guys think would be our input?
Mm,
Let's start with this.
Maybe
What
the
is going to be
height
our,
and the,
oh yeah, go ahead, Sarah. Sorry.
excuse me. I was going to say the height and the width. I apologize. I'm also starting to get sick, so
Yeah.
talking
Oh,
kind of hurts.
that's the worst. I'm sorry. And then Amber said the list of window openings. So yeah, I think your guys' answers together complement each other really nicely. Okay, so you might have multiple windows. So however many windows you have, their dimensions, their height and width in inches. Okay, so that would be our input. All right. What would be our output for this?
Total cost.
Yeah, the total cost. Okay, all these things are written right here. Okay, so we have the total cost. That's our output. And then what will our processing be? I guess that's not written in here, but what will our processing be?
All the multiplying. Like
yeah,
all
the dividing and or the, I guess like how you put it together.
Perfect. Yeah. So I would say, for each window, I'll get the area, so width times height. And then for each window, I'd multiply the area of that window by 35. And then I would just add up the sum for each window. Do you guys agree with that?
Yeah.
Okay. Yeah. So really good, you guys. So just to write this out, we'd have a list of window openings, which you guys said, and then for each window, width and height, which you guys also said. Output is our total cost. Okay, frequently when I think about stuff like this, it can be helpful to think about the output first. Be like, okay, what is my end goal? What do I need to, and then I start thinking about what do I need to do to get there? And then our input for our programs will be what the user has to actually type in for our program to work. Okay, because if I had a program that said, like add up these windows, do this multiplication, that's great if I have that logic there. But if I don't have any input from the user, I'm not going to know what to actually compute, So I usually start off with output. Okay, what's the end goal of the program? I look at the input. What does the user have to put in there so that I can get to the output? And then I deal with my processing, which is sometimes the hardest part. Because a lot of the times, the input and output will be listed pretty clearly just in the question. You can see, hey, this is what we're going to shoot for. I want the cost. And for the input, it says window openings and then width and height. Any questions on this concept? Okay, if anyone can remember back to elementary school, we all had lots of math story questions. This class is going to bring you right back to that. Okay, lots of story questions. So get used to it, enjoy it. All right, another example. You've been asked to write a program that will read from the keyboard the radius of a circle and will output to the monitor the diameter, circumference, and area of the circle. All right, so what is our output going to be?
The radius of a circle. Right?
Okay.
That's our
diameter and circumference and
yeah,
area.
so Amanda, so the radius will be the input. Okay,
Oh.
I probably confused you because the last time I asked for input first. So the input will be the radius. And then Sarah, you had the output, okay? Diameter, circumference, and area of a circle.
Oh, okay.
Okay. And then for the processing, we'd have a little bit in there, something to compute each chunk of this. So yeah, any questions on this example?
Mm-hmm.
Okay. So again, looking at algorithms, I already kind of gave you an example of, having a recipe and I'm like working through a recipe. One thing to remember with algorithms is that you need to have really clear expectations and your steps need to be very specific. Okay. So for my last example with the processing, I couldn't just say, knowing that I'm going to output the diameter, circumference, and area. Is that what it was for those? Yeah. I had to specifically say, for each one of those, here's how I'm going to do it, and here's what it's going to give me so that I can output it over here. Okay. So looking at algorithms, same thing. If I forget to preheat the oven and I throw a pan of brownie batter in there, nothing's going to happen. okay? And that seems like a silly example, but as you're working through algorithms, you really want to make sure that you have every step there that you need, okay? So here's one example, okay? Go ahead and read through this and tell me what step or steps are missing in this algorithm.
Walking to the pantry is one.
Okay,
Yeah.
unless you have a super tiny kitchen, so walk into the pantry. What else? Oh, Amber said putting things down after you grab them. Wow, that I've never heard that one. You're right, Amber, good call. Okay, what else?
Opening the milk.
What did somebody say about the milk?
Opening it.
Opening the milk. Yeah, look at this poor kid. We never poured the milk in because we didn't open it. Okay, good. What else?
You don't have a spoon.
Yeah, you don't have a spoon. Okay.
Like silverware.
Yeah, good. All right, so this looks good, but if you really think about it, you can be like, oh yeah, there's all sorts of stuff missing. Okay, so good job, you guys. All right, computer programs. We talked about this a little bit last week. You know, we talked about the hardware and the different pieces of hardware and how they work together. And then we talked about software. We talked about different types of software. We have operating systems that kind of manage the hardware. And then we have applications that work isolated from the hardware that work within the operating system to perform a specific task. Computer programs are what make up that software, okay? They are sets of data that, or sets of code that contain data and instructions, okay? Data in these programs will be temporarily stored in computer's main memory. We talked about that last week, and more permanently on the hard drive. All right, so an example of this, anytime you're actually running code, that execution of the code is stored in the computer's main memory or in RAM. Very volatile, temporary, okay? But if I had code that was actually saved on the hard drive of my computer, then I could access it multiple times. I could have data stored more permanently on the computer if I had a program with a database, and so forth. Instructions are called statements and are similar to steps in an algorithm, just like we saw with like the recipe and this kid getting his cereal, and sentences in a paragraph. All right, so when we look at code, you can think of code as being split up into steps similar to what we just saw with like a numbered list or sentences in a paragraph. All right, these are frequently called statements. All right, they're lines of code that tell the computer what to do with the data that you're giving them. All right, and so if I come back here, you can see here's a JavaScript function, and each one of these lines of code ends with a semicolon to say, hey, this line of code is done. But each one of these is a statement to get us to where we need to go. Okay. Any questions about this?
Kind of like a map.
Yeah, it is. Okay, so looking at that, computers are very simple things, okay? They're not really that smart, even though they seem super smart. It's impressive how much they can do, but at the very base of a computer, they really can't do that much, okay? They're capable of receiving input and writing output. They can assign a value to a variable or a memory location. They can perform arithmetic with these guys, okay? We have subtraction, these are in a funky order, multiplication, division, modulus, addition, and then a negation operator, okay? Modulus, does anybody know what modulus does?
Is that the remainder thing?
Yeah, good job. So it's the remainder. So if I had 10 divided by 3, I would get like 3.3-ish, okay? If I did 10 modulus 3, then it would be like, okay, 3 goes into 10 3.3 times. It goes wholly into 9 3 times, which would leave 1 left over between 9 and 10. So 10 modulus 3 would be 1. Okay, like Sarah said, just the remainder after that division takes place.
Right.
And then we have the negation operator, which is just whoops, which just says, you know, anytime something is true, if I want to negate that, it'll just like basically flip a switch. It'll negate it. It'll make it false. Okay. It can compare, computers can compare two values. Okay. So if I'd said like 5 is less than 6, or check to see if 5 is less than or equal to 6, or any one of these. Okay. Less than or equal to, greater than or equal to, is equal to, and is not equal to. Okay. Computers can repeat a group of actions. Okay. If I had a piece of code, I could write it in such a way that I could repeat the same chunk of code over and over and over again for whatever reason. Okay. We can repeat groups of actions. And I can call a function and return to that function. Okay. So all high-level tasks that a computer can do, such as edit photographs, play music, search data, have a Zoom meeting, are all a combination of these simple tasks. Okay. Kind of mind-blowing. And any questions or comments on these?
I think the only one I was not concerned about, but just confused about, was the call and return. How does that work? Is there an example you can show us, or is that something that we're going to learn later?
Both. I can show you an example, and it is something that you're going to learn later. So in this example, and again, don't stress out too much. We'll cover HTML in week 3. We'll start covering JavaScript in week 4, and then we'll be stuck in JavaScript the rest of the semester. Okay. But in this HTML file, I have a button. Okay. So if I ran this, and I'll show you this in a sec, if I ran this, you would see a button on the screen. And when I click that function, or when I click that button, it calls a function. All right. As soon as I say on click, it will scour the script tag, everything inside of script, which right now is just this, and it will look for function, template function. It'll look for this guy. Okay. And so this is one example. If I have code executing, I can have function calls, which will basically be like, okay, I was kind of going top to bottom, but now I'm going to jump out of that and I'm going to call a different function. I could also have, let's say I had like function get area. I could say like return width times height. And so in here, if I said, you know, var area, var should just declare a variable or save that space in memory. And I could say get area, and it would call this function get area, and then it would return whatever I tell it to return. In this case, I'm doing a little bit of math, and then it would assign that to this variable. Okay. So so the function calls and returns can kind of change how the code runs initially. If I look at control structures, which is basically like order of operations, the flow of execution, by default, we go from top to bottom. Okay, so when you see a piece of code, it'll go from top to bottom unless there's any one of these things in it. Okay, we have selection, which is saying, you know, if something is greater than something else, then do this, you know, if else logic. We have repetition, to allow the same piece of code to be executed multiple times. We frequently call this a loop. We have function calls and returns, which is what I just showed you. So right here, let's say I had this line of code right here, then this function would run as soon as the user clicks on the button. I'd hit this line of code, then this one. Then as soon as I hit this, it's going to jump down to here. And then once I hit my return, it'll jump back up here and assign that to area, and then continue here, by default from top to bottom. Okay. And then try, catch, throw. We won't look at try, catch, throw too much in this class, but this is just a way to find and handle errors, okay, without having your code break. It's basically a way to be like, hey, try this. If it throws an error, we're going to catch it so we don't break any code, and we'll just keep on going with something else, okay? But we won't look at those too much in this class. So Sarah, I kind of jumped ahead a little bit with these control structures, but I thought it might help answer your question. Did that answer your question about calling a function and returning to that function?
Yeah. Thank you.
Okay, yeah. And then also to the other question, we will look at this more in the course. We will have simple functions like this for the first few weeks, and then later on you'll start making multiple functions, like in 2 months. Okay, so no rush. All right. Any other questions about this? Okay. Well, you guys, as short as that seemed, that was all I had for you guys today. Okay, so I would encourage you to read chapter 2. Everything that I covered is in there except for maybe the kid eating cereal and Boromir, let's be honest. Okay. But the concepts are there. So feel free to review chapter 2. And if you have any questions, let me know. But yeah, that's all I had for you guys today.
Cool.
So,
Thank you.
okay, you guys are welcome. If you have any other questions, just shoot me an email, let me know, and I'll look forward to talking with you guys soon.
Okay, awesome. Thank you, Brother Birch.
All right, you're welcome, guys. Have a great day.
You
Take
too.
care.
All right, bye.